Finding the perimeter and area of shapes. Remember that the perimeter is the distance around the outside of the shape. So what we have to do is find the total of all of the sides of the shape. The area is the space inside of the shape. There's usually a formula to find the area depending on which shape you're looking at. One important thing to remember is that perimeter is always one-dimensional. We use units like inches, feet, kilometers, or if it's on a graph, just units. Area, however, is two-dimensional space, and we use squared units like inches squared, feet squared, kilometers squared, or just square units if it's on a graph. Let's look at some examples. For this example, we want to find the perimeter of the trapezoid. Remember, perimeter is the distance around the outside. So what we're going to have to do is add up the distance of all four sides of this shape. We can use the distance formula to find those outsides of our trapezoid. We're going to do each side one at a time, starting with from A to B. From A to B, we have the points -3, 3, and 1, 5. We plug those into our distance formula, and then we simplify inside to get square root of 20. Don't forget, if you're using a calculator, that the parentheses are very important and you need to type those in. Now when we square root 20, we get a decimal, so we're going to simplify that using a factoring tree. You can see that we have 2 times 2 times 5. 2 times 2 is just 4 square root of 4 is 2. We end up with 2 times the square root of 5 as our simplified radical. Next, we're going to look from B to C. We use the points 1, 5 and 4, -1 in our distance formula. Simplify the inside. Don't forget parentheses if you're using a calculator. That's the square root of 45, which is also a decimal, so we're going to simplify that using a factor tree. We get 5 times 3 times 3, which means this simplifies to 3 times the square root of 5. Next, from C to D, our points are 4, -1 and 1, -5. We plug those into the distance formula, simplify on the inside, and we get square root of 25. That is a perfect square. It equals exactly 5, so we don't have to simplify. And from D to A, we have the points 1, -5 and -3, 3. We plug those into the distance formula. Don't forget parentheses if you're using a calculator, and simplify. We end up with the square root of 80, which is a decimal, so we're going to factor this. Now, when I get to this point, 5 times 4 times 4, I know that 4 is not a prime number. However, 4 times 4, that makes a perfect square, so we can pull out 4 times the square root of 5. It's a little easier if you can catch it at this stage rather than having 5 times 2 times 2 times 2 times 2 and doing a little bit more work afterwards. So as soon as you get a matching pair of factors, you'll pull them out to front of the radical. Now that we have all four side lengths, we're going to add them together. So how do we add simplified radicals? It's a lot like adding with variables. We're going to add 2 root 5 plus 3 root 5 plus 4 root 5 plus 5. These three parts that have square root of 5 attached are kind of like 2x, 3x, and 4x, where we're going to just simply add the 2, 3, and 4, and then keep the square root of 5 afterwards. 2 plus 3 plus 4 is 9, so we end up with 9 square root of 5 plus 5. We can't add the 9 and the 5 because the 9 has a square root of 5 attached, and the 5 does not. Think of them as like terms and not like terms. Everything with a square root of 5 is a like term, but 5 does not have a square root of 5 attached, so it's not like terms with the others and has to stay separate. Now let's see an example with area. For this example, we want to find the area of the triangle shown on the graph. We have the points A, B, and C with the coordinates listed. Remember, for the area of a triangle, it's 1/2 times the base times the height. Now it's very important that you look at your triangle carefully. Sometimes they can be rotated. In this case, we can just use this bottom edge as the base because it's horizontal. You want either a horizontal or a vertical line on your triangle to be the base. The height has to go exactly 90 degrees from that to the top point of our triangle. Sometimes that's a vertical line and sometimes it's a horizontal line if your triangle has been rotated or turned sideways. Just make sure you've got 90-degree angles between your base and your height. One should be vertical and one should be horizontal in the examples we're going to see. Now let's go ahead and find those numbers. The base goes from -6 to 6 on the x-axis, which adds 12 units from A to C, meaning that the distance from A to C is 12 units. The height goes from -4 to 4 on the y-axis. This is increasing by 8, which means that the height going from that base between A and C up to the point B is exactly 8 units. You can simply count squares if you need to on this step. Now that we know the base and the height, we're going to plug those into our area formula. 1/2 times 12 times 8, which is 48 square units for the area of our triangle.